Hi, Assalamualaikum warahmatullahi wabarakatuh. My name is Nurul Ismahani Binti Ahmad Idris, one of the group members that will present about digital modulation for communication systems. So, what is digital modulation? Digital modulation is a key process in modern communication systems that allows digital data to be transmitted over physical channels, such as wires, optical fibers, or through the air. It involves altering certain characteristics of a high-frequency carrier wave, such as amplitude, frequency, or phase, based on the binary data being transmitted. Why we use digital modulation? Digital modulation provides more information capacity, has a compatibility with digital data service, has a higher data security, better quality for communications, and quicker system availability. These are types for digital modulation, which is the first one is amplitude shift keying, the second one is frequency shift keying, the third one is phase shift keying, and the last one is quadrature amplitude modulation, which is a combination from amplitude shift keying and phase shift keying. Next is the term related to data transmission and modulation, which is bit and baud rate. Bit rate is the number of bits per second that defines the rate at which information is passed and very important in computer efficiency. While baud rate is the number of signal units per second that defines the number of symbols or signals per second, very important in data transmission. Baud rate is less than or equal to the bit rate, and baud rate also determines the bandwidth required to send a signal. Calculation for baud rate is the bit rate is divided by bits per signal unit.
Okay, Assalamualaikum warahmatullahi wabarakatuh. My name is Raja Nafisah Saidah, Binti Kamarudin. Next, I will cover for the topic for ASK amplitude shift keying. Okay, so what is a ASK? ASK is one of the modulation technique where the amplitude of the carrier wave is vary with 1 and zeros. So how ASK works? A high amplitude carrier signal equal to 1 while the low amplitude carrier equal to zeros. So 1 is that carrier wave is transmitted while 0 is not transmitted. Next, we have the general equation for ESK. So V and T is digital information signal, and while A divided by 2 is unmodulated carrier amplitude, and this is an analog carrier radiant frequency. So next, we have a binary ASK. The equation is lowercase n equal to uppercase n baud, where the lowercase is bit rate and this is a baud rate. So this is example of waveform ASK. 5 bit rate is equal to the 5 baud rate. So next, we have the bandwidth here. So although there is only one frequency, carrier frequency, the process of modulation produces a complex signal. That's a combination of many simple signals, each with a different frequency. However, the most significant one are those between FC, this one, and FC plus n baud divided by 2, and as FC as a carrier frequency and n baud is as the baud rate. So next, we have the example ASK waveform using a Scilab software. So the green one is carrier signal which a high frequency with a solid non-sodium waveform, and the red one is a binary message that consists of 1 and 0 that used to control the amplitude of the carrier. So the blue one is the result of the superimposition of the message and the carrier that is transmitted over the communication channel. So next, we have the ASK in real world application. That is the first cellular phone here. So let's watch the video how it works.
Behind mobile communications. When you speak on your phone, your voice is picked up by your phone's microphone. The microphone turns your voice into a digital signal with the help of a MEMS sensor and IC. The digital signal contains your voice in the form of zeros and ones. An antenna inside the phone receives these zeros and ones and transmits them in the form of electromagnetic waves. Electromagnetic waves transmit the zeros and ones by altering the wave characteristics, such as the amplitude, frequency, phase, or combinations of these.
Okay, so that's all for the ASK. So thank you for listening.
Hi, my name is Ain and I will continue present for digital modulation and my part is frequency shift keying or FSK. So, frequency shift keying is a digital modulation technique extensively utilized in modern telecommunication and data transmission systems. It involves changing the frequency of a carrier signal to carrier information. FSK is based totally on the principle of varying the frequency of the carrier wave according to the digital input sign. This modulation technique is efficient and sturdy, making it appropriate for numerous programs in communication system. Frequency shift keying have two. First is modulation. The FSK modulator block diagram comprises of two oscillators with the clock and the input binary sequence. The second one is demodulation. The main method FSK detection are asynchronous detector and synchronous detector. Involve envelope detector. So next is how FSK works. Frequency shift keying binary record is represented by shifting the frequency of the carrier signal between predefined frequencies. Typically, a high frequency represents one binary digit, typical 1, at the same time as the low frequency represents the oldest digit is 0. The frequency shift occur at price period synchronous with the data transmission process. The key advantage of FSK is its robustness against amplitude variation and noise, as the information is encoded in the frequency rather than the amplitude of signal. So the next one is frequency shift keying for bandwidth. As you can see, this is graph for bandwidth, amplitude, frequency, and this is calculation bandwidth equal to Fc1 minus Fc0 plus n bound. So what is bit and bound of FSK? As you can see this graph, this is bit and this is bound. And this is calculation for bit and bound. Application for FSK. Despite its bandwidth limitation, FSK is still used today in certain situations where high reliability transport is needed for low bandwidth application. Common use cases for FSK or close variants include pegging communication system, color identification, and utility metering.
And the next is I will explain about the last types of digital modulation, which is phase shift keying. What is PSK? Phase shift keying, or we call it as PSK, is a digital modulation technique where the phase of the carrier signal is changed by varying the sine and cosine inputs at a particular time. PSK is a way to send digital data in binary using a wave called a carrier signal, and the wave phase, which is its starting point, is changed to represent the data. The amplitude and wave, however, remain constant, and also the phase during each signal unit is constant, and its value depends on the bit, D bit, or 3 bit. PSK is not susceptible to noise or not bandwidth limitations. It is, however, limited by the ability of the equipment to distinguish small difference in phase. PSK have a few types, and depending upon the phases, the signal shifted into binary phase shift keying, BPSK, quadrature phase shift keying, QPSK, or a higher order PSK. So, how PSK works? In binary PSK, BPSK, the wave phase might be 0 degrees for bit 0 and 180 degrees for bit 1. In a more advanced method like quadrature PSK, QPSK, two bits are represented by four phases such as 0 degrees, 90 degrees, 180 degrees, and 270 degrees. The adjusted wave is sent through a channel, and the receiver compares the phase of the wave to decode the original data. Types of PSK. This one is the binary phase shift keying (BPSK), or we can call it as 2PSK. The sine wave carrier takes two phase reversals such as 0 degrees for bit 0 and 180 degrees for bit 1. BPSK is basically a double sideband suppressed carrier modulation scheme for a message being digital information. And to calculate bitrate, the bitrate value is equal to baud rate value. And for width 2 equal to 2 e to the power of 1 with different phases, each phase can represent 1 bit, and this is a table and the constellation diagram for BPSK. And the next type is quadrature phase shift keying (QPSK), or we can call it as 4PSK. The sine wave carrier takes four phase reversals such as 0 degrees, 90 degrees, 180 degrees, and 270 degrees. PSK can be done by 8 or 16 values also, depending upon the requirement. And to calculate the bitrate for QPSK, it's need to times with 2, which is 1 bitrate equal to 2 baud rates. With 4 equal to 2 to the power of 2 with different phases, each phase can represent 2 bits, or we call it as d-bit. And this is a table and constellation diagram for QPSK. The next one is higher order PSK, or we can say 8PSK. We can extend by varying the signal by shift of 45 degrees instead of 90 degrees like in 4PSK. With 8 equal to 2 to the power of 3 different phases, each phase can represent 3 bits, or we call it as 3-bit. And this is the table of the 3 bits and constellation diagram for 8PSK. Alright, the bandwidth of PSK. The minimum bandwidth is required for PSK transmissions is the same as minimum bandwidth that required for ASK transmission. The calculation for bandwidth is equal to n baud, which is the value of baud rates. And the bandwidth is similar to SSK, but data rate can be 2 or more times greater. Before I show you a real-time application for PSK, here is the example of the waveform for PSK. The red one is the basic signal, and we can say for the amplitude, the value of amplitude. And the green one is the carrier signal, and the blue one is the output of the PSK signal. So let's see the video for real-time application of PSK.
There are a number of applications that use offset and differential PSK. Offset QPSK is most often found in satellite systems due to its spectral efficiency and constant power envelope, although it's often used for other types of data transmission and broadcasting. A special variant of offset QPSK, called shaped offset QPSK or SOQPSK, is used in many telemetry applications. A well-known application of differential PSK is Bluetooth, and DPSK is also used in some RFID applications as well.
Okay, so that's all for real-time application of PSK, and that's all for PSK part. And that's all from us. So thank you for listening.